And the simplest, one of the simple scoring schemes that you can think of is the Jaccard coefficient. Like, recall that we uh, discussed this Jaccard coefficient in chapter 3. It's a measure of how much sets A and B overlap. Okay, so the Jaccard coefficient between a set A and a set B is the size of the intersection of the two sets divided by the size of their union. And this coefficient is always between 0 and 1. It's 0 if the two sets are completely disjoint, that is, if there is no overlap. And it's 1 if the two sets are completely overlapping. Okay, so either the two sets could be identical, or even if one is a subset of the other, you could have a Jaccard coefficient. Oh, sorry, if one is a subset of the other, then still you would have a value that is less than 1. So it's going to be 1 if the two sets are actually identical. And in general, the score is going to be between 0 and 1, okay, when there is a partial overlap. And note that the two sets here, A and B, of which you are taking the Jaccard coefficient, they don't have to be of the same size. And whatever be the size of the two sets, the Jaccard coefficient value is going to be between 0 and 1. So let's take an example. Actually, let's look at the simple query example we saw of India. So if a document contains the word India, then the intersection. So what are we taking what is the set A and what is the set B here? The set A is the set of terms in the query, and the set B here is the set of terms in the document. So these are the two sets between which we are taking the Jaccard coefficient. So we're going to calculate the value of the Jaccard coefficient between the query and every single document in the corpus. And then we are going to sort the documents in decreasing order of the value of this Jaccard coefficient. So let's take an example to illustrate this. Let's take the example given in the slides. What's the score of what's the score between the query and the document for this example? So let's say the query is Ides of March. Okay, Ides of March stands for the 15th of March, which was the day when Julius Caesar was killed. So document 1 says Caesar died in March. Document 2 says, it just says the Long March. So how do we compute the Jaccard coefficient between the query and the first document? What's the value of the these two Jaccard coefficients?
Uh, 1 by 6 and 1 by 5.
This is 1 by 6 and 1 by 5.
Yes, so if you're going by actual, like the tokens as opposed to bywords, then 1 by 6 and 1 by 5.
Yeah. So when we want to calculate the Jaccard coefficient between query and D1, how many terms are common to the query and D1? Just one. Okay. In fact, that's also the case with the query and D2. So March is the only term in the query that's present in document 1, and March is the only term in the query which is present in document 2. You can turn off the microphone now. Okay, so the numerator is going to be 1 in both cases because the size of the intersection is 1. And in the first case, the denominator is the size is the total number of terms in either the query or the first document. So that's 1, 2, 3, 4, 5, and 6 here. We're not going to count this because this has already been counted here. So 1 by 6. And likewise here it's 1, 2, 3, 4, and 5. Again, we're not going to count this because it was already counted here. Now, think about it conceptually. Which of these documents, as a user, if you had this query and these were the two documents, which of these documents is closer to the query? Which of these documents is more relevant to the query? The query is Ides of March.
Document 1, sir.
Yeah, because Ides of March is typically the the Roman phrase for 15th of March, which is the day when Caesar died, and document 1 is referring to that event, whereas document 2 is referring to some other meaning of the word March. Okay, here the word March does not stand for the month, stands for some other meaning, and it's not relevant to the assassination of Caesar. So this is the document that's more relevant to the query. But if you look at the score, document 1 has a lower score than document 2. Now that indicates that this scoring scheme we have come up with is not exactly proper. And you can see that if you had considered a single query as we were originally going to do. If I compare this query term, so there's only one term in the query. So let's say there is a document um, of size uh, 1000 which mentions the word India, and there is another document of size, I don't know, 5000 tokens which also mentions the word India. Now can we say that the document of a smaller size is going to be more relevant? Because this is the one that's going to have a higher score, because the denominator will be larger. The denominator will be smaller for this document, whereas it's going to be much larger if you calculate the Jaccard coefficient. So we don't, it's a little odd that the length of the document itself should determine the value of the score. Okay, because this score is sort of biased against longer documents. Even if the longer document is more relevant to the original query. Okay, so the other problem with this Jaccard scheme is that it doesn't consider term frequency. Like, recall that term frequency is the number of times that a term occurs in a given document. Okay, and what we expect is that if the term frequency is higher, then that particular document is probably more closer to the query than another document where whose term frequency may be lower for that query. Right? If there's a document which mentions the word India just in passing once, that's probably not as relevant as another document which may mention the word India 100 times. Right? And the Jaccard scheme does not look at the term frequency at all. That's one drawback. Of course, the other drawback that we just saw was that uh, the length of the document is affecting the score in a very strange way. Okay, longer documents are getting a lower score even if they are more relevant. So we need some way of normalizing for the length. Okay, so that differences in the lengths between the documents does not affect how close they are to the query.
Sir?
Yeah.
Sir, when we were doing precision and recall, there was a part about document unit. So if we make the document unit standard, regardless of this actual document size, would this be solved?
Yeah, that's one way to look at it. But then, defining the same document unit for documents of a variety of different types is not very realistic. For example, a particular, you know, a particular document may be smaller than whatever document unit you define. It's possible for, say, a tweet to be smaller. A tweet could be treated as a single document, and that's going to be smaller than that document unit most probably. So recall there also that the document unit did not have to be either too small or too large, right? And the problem is that if you're dealing with the web, then it's difficult to impose a single document unit size on documents of different types, because then you would have to artificially um, split apart paragraphs or sentences just to maintain that document unit size. So there are actually better scoring schemes that we're going to look at which address that problem. But the direction in which you're thinking uh, is good, in that you're trying to evaluate different possibilities to tackle this. So this is actually what you should be doing when you think of these design decisions. You have to see what are the advantages and disadvantages of different schemes. So we've looked at two disadvantages with the Jaccard scoring scheme. There is a third disadvantage, which is that not all the terms in a document are equally informative. Right? For example, if there is a stop word in a document, and if there is a stop word in the query, just because the two stop words match does not mean that the query is uh, closer to the document than another document where it's not the stop word which matches, but a more rare word in the query. Okay, so for example, if the query is capital of India, okay, and if you have two documents, one of them has the word of somewhere, and it may have the word India somewhere, and another document has the word capital somewhere and the word India somewhere. Okay, now this document, it, it may not be relevant to the query because it doesn't refer to the capital at all. It may be referring to the GDP of India, or maybe this word of appears somewhere pretty far off, right? But the point is that there are two terms here which match the query, whereas here there are two terms which match the query. But here, because one of the terms matching the query is a stop word, it's not very informative. Okay, it's not telling us that uh, this document is close to the query as much as these other terms, okay, which are more rare and whose appearance in a given document carries more weight than the appearance of just this stop word. Okay, so we need some way to accommodate this in our scoring scheme also. We don't want to weigh each term exactly the same. Okay, we want to give more weight to rare terms in the collection, because rare terms are more informative than frequent terms. Is that clear?
Yes, sir.
Okay. So these are the three problems with the Jaccard scheme. Okay, so we are going to later on look at a scoring scheme uh, called the cosine score, which is going to address this problem. Okay, which is also going to have some kind of normalization. Okay, so you'll have to wait until that point to understand this. This may not make much sense right now.